Am I audible?
Yes, sir.
Okay. So today we will learn about the conditional execution. That means I execute a certain set of instruction when a particular condition happens. Condition means what? If the answer is zero, do these things. If the answer is not zero, do this. If you are comparing the two numbers, if the one number is greater than the other number, do this operation. If the number is not equal or if the number is less than, you do certain operation. Or if the number is negative, do something. If the number is positive, do something. So basically, these are the general comparisons we require to implement whenever we write or develop assembly language programs. So checking for equality, checking for greater or larger, greater or smaller, checking for sign of a number. These are the three requirements generally we get whenever we want to implement the different logics in assembly language program. How do we implement those logics? The if and else statements, if statements, and implementing the loops. These are all possible using what is called as conditional execution. So today we will learn about the conditional execution, how we can able to work on the conditional execution. Let's take an example. I use an instruction move R0 and then I'm going to write 10. When I compile this program, it is 100% sure that the 10 is moved into the register. Work only if the condition is satisfied, otherwise don't work. That means that I am converting this instruction into what is called as conditional execution instructions. All the data processing instructions, what has been supported in the ARM, that is data transfer, arithmetic, logical instructions, we can convert those instructions into what is called as conditional execution enabled instruction. That means that as a part of the instruction, I can introduce some condition. If the condition is satisfied, that instruction is going to work. Otherwise, it's not going to work. Now, we know that what are the flags we have? We have the three flags are there, which are important other than the overflow flag. One is a zero flag, other is a carry flag, other is a sign flag. Now, let us think about introducing the condition based on these three flags. Let's go with one example. Now, I'm going to write an instruction now. I'm going to write an instruction now. If that instruction checks for the execution, I'm going to write an instruction which has got a condition. The instruction before executed looks for a condition. If the condition is satisfied, it will work. Otherwise, it will not work. I want to make that instruction a conditional enabled instruction. So let's take an example and we will do it. Now, let's say move R0 is equal to 0, 0. I am moving it. Now what will happen? R0 is equal to 0 and the flags are not going to change because I have not introduced a S suffix. Now I am introducing a S suffix. So we have already understood for the X suffix. So what is the first job of a suffix? So S introduces S, update the flags, all the flags. That is the meaning of suffixing S for the instruction. So whatever the suffix S introduces this concept called update the flags. I can use the S suffix for all data transfer or data manipulation instructions, arithmetic, logic, the move data transfer instruction, I can able to use it. Now, so I've used a suffix. Now, since I have loaded the 0 into the R0 register, then what will happen? The contents of R0 will be loaded 0. Since my answer is 0, the zero flag will be set. Now I'll introduce condition execution enabled instruction now after this instruction. Now I'll say I want to move into another register, move into R1, some number, let's say I'll take 10. This is a normal instruction. Now I'll introduce a condition here. So that means that any instruction, I can introduce a condition into that instruction to make it condition execution enabled instruction. What is I'm checking for? I'll check for zero flag. Zero flag can be having two values, the previous instruction. Either it would have set the zero flag or it would have cleared the zero flag. Now I'm checking for a condition called zero flag set condition. That is, if it is equal in the sense previous is, so that previous result is 0. So I'm checking for equality condition called, let's say, EQ. Now what does this instruction will do it? So if the zero flag is set, that means that equality condition is set, zero flag is set, that is set is a indication for equality. So I'm checking for zero flag set condition now. So now one instruction I have written it. So now what I'll do is I'll execute this instruction. We will see that what will happen with the execution of this instruction. Now, if you look at the register, so now move R0 is equal, I will expand the register. So now R0 is loaded with a 0. Since R0 is a 0, the zero flag has been set. Now look at the equality condition. What is this instruction? It's not a move instruction. So what is the meaning it carries? Move instruction and equality condition. Two things are there embedded in the instruction. One is the meaning of the instruction. Other is what is the condition I'm looking for it. If the condition is satisfied, then the move instruction is going to work. That is how the meaning of conditionally execution enabled instructions work. So what is the meaning? It says that the condition, whatever you specified, what is the condition? EQ. EQ means
equalities.
Equality. If the EQ flag is set, in the sense zero flag is set, then the condition is satisfied. So if the condition is satisfied, then what will happen? The move instruction is going to work. We will see that now. Now the zero flag is set here. The equality condition is satisfied. R1 will be loaded with what value? 10. Keep looking at the R1 register. Now it will become R1. That is 10 means A. So hexadecimal equivalent of 10. So loaded, it works. Now what I'll do is, I'll do 2-3 changes here. One is I change the equality possibility. What are the equality other possibility? NE. So that means that, so now looking at the zero flag, zero flag. So what are the conditions possible? So you have one is EQ is possible, one is NE is possible. Now I'm checking move not equal, R1 is equal to R0. Now let's see that whether does it work or not. What is the end of this program? Now again, I'll enable the view of the registers and the flags. So now look at that. The flag is 0 is set, but the move instruction is suffixed by a condition called not equal. Not equal means move instruction is going to be executed only when the zero flag is 0. The zero flag is not set. Say, look at this now. So now if I execute it, what is the value? Keep looking at R1. Now R1 is what? 0. Since the condition is not satisfied, move instruction should not work. See, now 10 has not come to R1. So what is the value R1? Still it is 0. So that means that the meaning of this type of instructions is that conditional execution enabled instruction is that. So you can able to suffix the condition to any of the data manipulation instruction. If the condition is satisfied, then that instruction is going to work. Otherwise, it's not going to work. So generally, why do we use equal and not equal symbols? Because we know that when we use a zero flag, so before that, we would have compared the two numbers for equality. If they are equal, correct now. So then that means that zero flag is set. So instead of move as, now I'll change the instruction to another instruction so that, so you will get a meaning for the EQ and NE statement. So CMP is a very commonly used or commonly available instruction in all the processes assembly language instruction set. It's a very commonly available instruction in assembly language of any processor you take it. Compare is basically used to compare the two operands. Here the operands are what? Registers. So I can compare the two registers. Let's say R2 and R3 I want to compare. So before that, we have to load some numbers. It based on the logic, you would have got the two numbers you are comparing. Now in this case, I load a number, move R2 equals hash 10, so or hash 5, some number, then move R3 hash 5. So except for all other instruction, except for compare, all other instruction requires S suffix to update the flags. In case of compare instruction, suffix is not required because comparison instruction is designed in such a way that the flags are automatically updated. You don't require to put a suffix here. It's not required. See that it's not required because why? Compare instruction update the flags. Except for compare, all other instruction you require suffix. Only compare it's not required. Now, whenever you use a compare, what is the purpose of the compare instruction? It is called as compare instruction is also called as pseudo subtraction. It's also called as pseudo subtraction. So compare instruction is nothing but pseudo subtraction. So what is the meaning of that? What is the meaning of a pseudo subtraction? So pseudo subtraction is mean that if I use a subtraction instruction instead of compare here, R2 minus R3 is performed and the result is stored in R2. That means that destination is going to change. And if I use an S there, the flags are going to affect it. Now what I want to do, I want to compare these two numbers. How do we compare? You have to perform subtraction and then change the flags. Then only the comparison can happen. For example, why do we compare? We compare for two things. One is for checking for equality or greater or less than. These are the two things we want to derive out of the comparison. How do you do that one? It's only possible is what? By subtracting. By subtracting two numbers, you can check for equality by looking at a zero flag. You can look at a carry flag to find out which is lesser or greater. But if my intention is only to compare of the two numbers, then one thing which is not required is happening here in the subtraction. What is happening? You are comparing R2 by R3 by looking at the flags, but R2 contents is lost. Because why? When you subtract, R2 is equal to what? R2 minus R3. So many times it's not required for me to change the contents of the two registers, but I want only to compare. That means that flags to be affected. In such cases, we use compare. So compare is nothing but pseudo subtraction. It's exactly same as subtraction with the suffix yes, but only thing is destination register operand is not going to be modified. What is the destination here? R2. That means normally if I use a subtraction, it is nothing but what? R2 equals R2 minus R3. And the flags are going to change. In this case, what will happen? R2 minus R3 happens, but the contents of R2 and R3 is not going to change. That means the result is not stored anyway. Only subtraction is done pseudo. That is why we call it a pseudo subtraction. Subtraction answer is not stored anywhere. The contents of R2 or R3 is not changed. Then what is the use of a comparison instruction? To change the flags, to update the flags, so that I can take a decision whether they are equal, greater, or less. Now what I have done, I've used a move two numbers, I've checked. Now we'll see that I have not used S also. We will see that how does it work. In this case, actually 10 should not be moved to R because why? They are equal. So I'm audible.
Yes, sir.
So now I have loaded the two numbers. R2 is equal to 5, R3 is equal to 5. I load it. Now I am comparing. Look at the flags. Now all the flags are 0 now. I have not used yes, but I set compare, implicitly update all the flags. Keep looking at the flags. Now when they subtract both of them, what flag to be changed? The 0 flag has to change. Now I've executed the instruction. See, the 0 flag has changed, carry flag is also changed. So in the subtraction instruction, so one thing you have to remember is you are subtracting the two numbers, two flags are going to change, which is for a unsigned numbers, which are very important for me. One is the 0 flag, other is a carry flag. So carry flag, you have to understand one concept here. Whenever you subtract two numbers, R2 minus R3, always when R2 is smaller than the R3, that means that carry flag will be 0. Whenever R2 is greater or equal to R3, so then the carry flag will be set. So this we will see in details. So we will take one two numbers and subtract, and we see the 2's complement method, how it will be performed. But now you have to understand that. So whenever you subtract two numbers, if the first number is greater or equal to the second number, the carry flag will be set. That you have to understand, because we're using the 2's complement method. So that is how it works. We will see with an example. So another thing, when R2 is less than the R3, carry flag will be reset. It will not be set. So this we will remember it now for a moment. Now what has happened? So since the 0 flag is set and the not equal condition is not satisfied, the 10 is not moved to here. So now what we'll do, I'll make it again equal condition. I'll make it again. I'll compile that one. We will see that whether 10 will move or not. So now I'll execute the program. So keep looking at the statement. Now I will, same flags are going to change. So now move equal. Now R1 is what? 0. Now I'll execute that instruction. It becomes a 10. So that means that I can use S suffix for any of the instructions and look at the flags. Then I can implement the conditional execution instructions. Or before that, I can use a simple compare instruction, perform the comparison. Then I can able to use the conditional execution instructions. It depends upon the logics what you develop it. So now we have understood that how a compare instruction is used to compare the two numbers and set the flags and then take the decisions. Now I want to introduce the other two conditions. So we have seen equal and any not equal. I want to introduce other two conditions which are very frequently used, which is based on the carry flag. So now carry flag. Now I want to use. Now what are the two conditions which are provided for the unsigned numbers if I use a carry flag? One is I can directly use carry set and carry clear. I can able to use it. Or I can use plus and minus the numbers. I can able to use. Also I can able to use it. So I will use carry clear and the carry set first, and then I'll use the minus and the plus also. Now, so the two things which is available is this carry clear, carry set, and carry clear. Now I have used carry set. I'll be using it, carry set. So I'll use carry set. So now, and then I can use carry clear. These are the two options possible. And also I can use, so plus and minus I can able to use it. So along with that, I can use plus, one option I can able to use it. So other is I can use the minus also. I can able to use it. I can able to use. So we will see one by one. First we'll use the carry set. Now I will just take some unequal numbers, because when do I use carry set and carry clear? If I'm interested in comparing whether the number is equal or greater, I'm just checking with the carry flag. If the equality means, I'll be always checking for equal or not equal. So now I'll compile this program. So I'm subtracting a smaller number from a larger number. In this case, I am subtracting a smaller number from a larger number. I'll execute the program. So now I'll execute the first two instructions. Now I'll finish the third instruction by looking at the flags. Now what I'm doing is R2 is what? 6. R3 is what? 5. I said whenever you subtract a smaller number from a larger number, carry flag is set in ARM controllers. If you same thing, if you look at an Intel processor, 8051 or 8086, 286, 386 Pentium, Intel processors, it is other way. So when you subtract a smaller number from a larger number, the carry flag is 0. When you subtract a bigger number from a larger, carry flag is set, because carry flag means it acts as a borrow flag. See, carry flag is also called as a borrow flag when you're doing subtraction. In Intel process, it's like that. But in ARM process, it's reverse. So when you're doing coding with an 8051 or Intel-based microprocessors, you should be careful when you look at this flag. But here, since we are doing ARM product, remember that it is always that when you subtract a smaller number from a larger number, carry flag is set. Keep looking at this flag now. So now I'll execute that instruction. See, the carry flag is set. So what you have to understand, when you subtract a smaller number from a larger number, carry flag is set. Other way, so when you are, even if it's an equal also, carry flag is set. We have seen in the previous case. So when this R2, there's a, when you subtract, when both are equal also, carry flag will be set. Or when the first number, that is R2, when the first number, first operand data is greater than the second operand data also, carry flag will be set. So now carry set condition is, we have to test it. Now R1 is what? Now R1 is 0. Now since carry flag is set, it should be loaded with what? How much? 10. See that we are loaded with a 10. So that means since the carry flag is set, it is being executed. So now we were able to analyze how CS is work. Now we will just see with a CC one condition. So now I'll compile. Now I'll go back to the code. Now I'm using a CC. So execute the first instruction. Then again, the compare instruction. Carry flag is set, but the condition is what? Move CC means what? Only when the carry is clear, they should work. Since carry is not clear, carry is set, it should not work. So keep looking at R1. Now I'll execute the program. It is not set. So this is how. So the carry flag and the condition can be used. In case of signed numbers, we can also use what is called plus and minus. What is the meaning of plus and minus? When I compare the two numbers, if the answer is positive, correct now, the condition is satisfied. So if I say plus here, so clearly, what does it mean that? So if in the previous compare instruction, or subtraction instruction, if the answer is positive, then this instruction will be, the plus will be valid. The plus means plus is satisfied. When the answer is positive, we know that when you subtract a smaller number from a larger number, answer is positive. So in this case, we will see that I am subtracting a smaller number from a larger number. That means that, so answer is positive, it should work. So we will compile this program again. So I'll execute till compare. So as usual, the flag is going to change. But now don't look at the flags. Look at the meaning here. So when you use CC and CC, look at the flag so that there is a meaning is there. When you look at a plus, don't look at an answer. You just look at the values, whatever here. So there's no confusion with that. So look at the previous operation. Now look at, so R2 is 6, R3 is what? R3 is 5. 6 minus 5 is what? 1. That means that answer is positive. So that move into the R1, the 10 value, if the previous answer is what? Positive. So that is, in this case, it satisfies. So R1 should be moved to 10. Look at this one value. So it has become moved into 10. So this is how I should be able to use it. When you use plus, when you use plus, minus, or equal and unequal, don't require to look at the flag. Look at the previous operation and understand the meaning out of it. It's good enough. So now I'll just change the last condition. So minus, I'll use it. Now I'll compile my program again. Am I audible?
Yes, sir.
So now I'm checking for the last condition. Now I will execute the instructions. Now the flag is also going to change based on the result. Not required to look at the flags, but just understand that flags have changed. Now, how does this instruction work? Only look at the previous meaning of the instruction. Since I am subtracting the smaller number from a larger number, my answer is positive. That is, so 1. But here I'm looking for minus condition. That means that since minus condition is not satisfied, answer is positive, this instruction is not going to work. So what is the value in R1? Just look at that. R1 value is what? So it is 0. That means that instruction is not satisfied. This is how these instructions and the compare instruction I can use to implement my logics. So I can attach now these suffixes, conditional suffixes, conditional execution suffixes. They're called as conditional execution suffixes. How many such suffixes? There are 15 such condition codes are there. So we will learn as and when required these suffixes. Now I have told you the suffixes related to the 0 flags and the carry flag for unsigned numbers. So what I have told you for unsigned numbers. So how many suffixes we have learned? 6 suffixes we have learned now. So EQ not equal, both are related to what? So 0 flag, then this is related to carry flag, and these 6 flags I'll be using for unsigned numbers. I'll be able to use it. Now, now we will modify this program to find out the largest or smallest of the 2 numbers. So there are easy way you can able to implement that using what is called as the compare instruction, and using a move instruction itself you can able to implement very easily. You can able to implement it. So we know that if I want to compute a larger of the 2 numbers, I can just load those 2 numbers into the 2 registers. I can compare them. Then I can able to use proper instructions. Now what I'll do is I will write into my program. So 2 numbers I'll take it. I want to find out the largest or smallest of 2 numbers. So I'll take, let's say, R1, one number, some number, let's say 100. I will take another number, let's say R2. So let's say 160 or something. I take other numbers. Now I want to load the smallest of these 2 numbers or the largest of these numbers into R0 registers. So what should I do it? Whenever you are comparing 2 numbers, you have to perform an operation. See, it is nothing but like a statement. In a C language, how do you write a statement? So if you want to compare 2 numbers, how do we write? We start writing the code. If A is greater than B, this is what we do it. Yes or no? How do you implement this A greater than B or A less than B in a C language? Sorry, in assembly language, because this construct is not available. This construct itself is not available. You have to implement construct yourself at the low level language like an assembly. How do you implement a construct? First, assume that the 2 registers, whatever you are using, in this case A and B are what? I'm using R1 and R2. Now I have to implement if construct. So for a greater than condition, I have to instruct. Whenever you want to use an if construct, immediately you write instruction called compare. This is what you have to remember that. So in a low level language, if construct is implemented by what is condition called as if construct. So that means that you want to implement if construct, you have to perform what? Comparison of the 2 numbers which you are doing, either comparison or subtraction. So better is always comparison because you are not losing the destination register contents. So use a compare. So now I have to implement if A greater than B. So I use a compare and the 2 registers what I use. So A is nothing but R1 for me. So and then B is nothing but R2 for me. So it is not completed. I have just compared. What was I have done? So to satisfy this one, I performed a comparison, but it's not complete. To make it complete, now you have to implement a logic. Yes or no? So what is the logic is required? So generally in if and A, what we do, if the condition is satisfied, then I'll put certain set of statements here. I'll put certain set of statements here. I'll be putting the set of. So if this is not satisfied, then what I'm going to do, I'll be doing what is called as else. I'll be implementing it. Now we will see that how we can implement this type of structures in the assembly language. Now, so I have done a comparison. Now the flags has changed. You can implement in a simple way using what is called as conditional execution enabled instructions. One way, simple method. Or when if the condition is satisfied, you have to do multiple things here. That means that it's not moving, setting on register. In this case, it's a very small requirement. What is a small requirement? I have to find out smaller or a greater of 2 numbers. So in a single statement, assembly instruction, I can satisfy it. But in certain cases, what will happen if it's greater than B, I have to do multiple things. That means that I have to do step 1, step 2, step 3. That means 3 tasks I supposed to do it. In such cases, it is not possible in a single instruction you can able to implement. So when the task is very simple, which you can finish in a single instruction, I can use a conditional execution instructions. If the task is not completed in a single instruction, I can always use what is called as this type of structure. If and else structure I can implement using what is called branching instructions. We will do both the cases today. So now, if Now, since it's a very small case of moving the largest number into one of the register, I can able to simply like that. After the compare instruction, I can write move instruction, two move instructions, move CC one case, move CS one case. That is, I can finish. That means that. So if I want to find out the largest of the number, so largest of the number means what? You are larger. That means that when R1 is greater than R2, so we know that the carry flag will be set. Carry flag will be set. That means that this condition is satisfied. I'll come here. So my R0 is equal to largest number. Where is the largest number is available now? In case of this case, so I'll be using R1. Let's say in this case, I'm comparing these two numbers. R2 is smaller than R1 in this case. So what is the case? R2 is smaller than R1. So then what will happen? This condition will satisfy. Now the other condition, what is the other condition? So I can directly write now R0 is equal to R2. Now let's analyze in this case. So now which is greater here? 160 is greater. That means that R2 is greater than R1. That means that R1 is smaller than R2. That means that which is a flag is going to change. The carry clear CC flag is going to meaning will be satisfied. So as we already understood that whenever the first number is greater than the second number, CS will be satisfied. So in that case, which is a higher number? R1 is a higher number. So R1 I will load into RC. So whenever the R1 is smaller than the R2, carry flag will not be set. That means that this condition is satisfied. So in that case, so which is a larger number? So larger number is what? R2. R2 will be moved into R2. So by the end of this program, R0 will be having the largest of these two numbers. So we will verify now. So how it works. Now, now look at these two numbers now. So I have loaded R0, R1 is equal to 100. There is another but 64 hexadecimal equivalent. Now 160 hexadecimal equivalent of that is A0 I load. Now I'm comparing these numbers. Look at the flags now. Since R1 is in this case, R1 is smaller than R2, the carry flag will be clear. It's not set. When does the carry flag set? Only when R1 is greater than R2, carry flag will be set. In this case, it is not satisfied, so it will not be set. You can just check here. See that carry flag is not changed. It's not set. So now we come to here. So since carry flag is not set, this instruction is not going to, this instruction is going to work. Because why? Carry flag is clear. See that it's clear. Carry flag is clear. It's not set. So that R2 will be moved. That means that this instruction will be going to execute now. So the meaning of that instruction will be satisfied. Now look at R0 has got what? A0. That A0 is what? Hexadecimal equivalent of 160. Now, so this will not satisfy. See that now R0 is also has got already A0. Now R1 is contains what? R1 contains 64. That will not execute. So see, look at that. That is not executed. That is second instruction is not executed. So by writing the instruction like this, after the compare instruction, always any one of these instructions is going to work. So now this compare along with this instruction is equivalent to if A is greater than B, do something, else do this. So this is how you can implement an assembly if else construct. But in this, what is the limitation of this construct? If you are able to satisfy, if the condition is satisfied, if you are able to fulfill the result with a single instruction, you can always do like this. Otherwise, we require a branch instruction. Now, what we will do now, we will do that. Now we will implement the other case with a branch instruction now. So now I have understood the meaning of this instruction. Now I'll introduce the concept called branch instruction. We already used a branch instruction here. What is the meaning of a branch instruction? So B means it's a branch. Branch to where in this case? Branch to a label called stop. Where is a label? Step. That means that it's a looping here. If I write a branch instruction, that means that whatever the address I write here, it will go to that place. If I write an address, repeat, so or continue or something, then if I write the continue label here, then what does it mean that? So that means that so it will go to a label called continue. So that a B instruction is nothing but a branch instruction. As it is, if I use a branch instruction, it will move to the label whatever I specify here. So this is called indefinite loop, because you are not going to come out of this program, because it's going to always hit branches here. Now, the branch instruction is of two types of branch instructions are there. One is called the conditional branching, other is called as unconditional branching. Now, whatever I've used till now B is it unconditional branching. Now I'm going to use a conditional branching. How do you implement a conditional branching? Like whatever we did for other instructions, adding the suffix called condition codes to the instruction, same way we can add a condition codes to the branch instruction. Then the branch becomes a conditional, unconditional branch become a conditional branch. For example, if I say branch equal, then what does it mean that? So we know that what is the meaning of equality, that is zero flag is set. So that means the branch is going to happen only in the previous operation has set the zero flag. So like this I can able to use it. For example now, so branch plus, what does it mean that? So it branches to another instruction. It branches to what? Another instruction, another label, only when the previous operation produces the positive result. Like that, I can able to use the branch instruction like this. I can able to do it. Now we will see that how I can able to use the branch instruction to satisfy that one. So now I'll use the other label called less than label. I'm going to use it for assigned numbers. So I'm introducing now one more label. So it's called as less than label. I'm using it now. Now I'll implement the if and else structure now. So I'm introducing now. I can use a plus and minus also, but more meaningful label is called less than or equal. So less than or equal, I will use it. So what does this one less than means? So this branch instruction is based on the previous result. What is the previous result? It is a comparison of R1 and R2. You are comparing the two numbers. You are comparing. So you are comparing the two numbers. So what are the two numbers you are comparing? So R1 minus R2, you are doing it. So what I'm going to do here now, so you have to read this instruction like this. So first branch, so you should read the branch first. Read B means what? Branch. Now go to here. If R1 is less than R2, then come back to here. Then, so less than R2, then you go to a label whatever specified. Let's say I will write a label. I'll write a label. So continue or something, I'll write a label now. Or so some less, I'll give a label now. So what does it mean that? Branch, I'll repeat again. How do I read it? Branch, go to the previous instruction. If R1 is less than R2, then go to a label called less. So now I will give some space to implement if and else structure. I'll go to the less. Now this is my what? My label. Now the two areas are there. So between the BLS instruction and the label is one area. Like in case of if construct, no, you see there's a one area is there. After the less, there's another area is there. There's another area. So now, so compare and BLS is equivalent to what? If condition. If A is greater than or less than two numbers. Now after that, two areas are there. Condition is satisfied, one set of instructions or one set of code to be executed. If not satisfied, other set of code is executed. See, this is nothing but if condition statement. Now the two areas are there. This is one set of code, you can write it here. Other set of code, you can write it here. How do you look at that? You can look at the case now. Now let's say I want to find out the largest of these two numbers. So if it is less than, if R1 is less than R2, it should go to less here. So it should go to here, less case. Now, if R1 is less, that means that which is greater? Which is greater? When R1 is lesser, R2 is greater. So that my answer, I will store the answer in R0, move R0, comma R2. Now other code. If the condition is not satisfied, if the condition, that means that if R1 is less than R2, it will branch here by chance. If it's not less than, then what will happen? This condition is not satisfied, it will not branch. It will come to where? The instruction which is next to that. So that means that if the condition is not satisfied, BLS is not satisfied, it will come to here. That means that R1 is not less. In such cases, what? R1 is greater. So move R0, then so R2. Move R0, comma R1. Sorry. So now I have completed if else structure using a branch instruction. See, if BLS, if the R1 is less than R2, it comes here, execute this statement. If this condition is not satisfied, that is R1 is greater than R2, then it comes and execute this statement. But we have to make sure that either this will execute or this will execute. Am I audible?
Yes, sir.
Am I
Yes,
audible?
sir.
Yeah.
Yes,
So
sir.
I will execute either this condition or this condition. How do you implement in assembly? In this case, in the previous method, whatever I write, only one single statement is there. It is not single statement. You can be able to introduce multiple statements. Look at that. So if the condition is this condition satisfied, I can write not only one instruction, many instructions I can write one by one by below that. If the condition not satisfied, if the condition is satisfied, I can write multiple instruction here. That means that, so there is a place here to write multiple instruction here also. But you have to make sure that either this set of instruction will work or this set of instruction is going to work. You have to make sure that, otherwise what will happen, both will execute. If you don't take care, then what will happen, first this will execute and the microcontroller does not know. Immediately after this, it will also execute this instruction also. So it is your responsibility to make sure that either this or this will execute. Then what you have to do, put at the end of the first block. So see, in this case, my requirement is only one instruction, so that I have to stop here. I should make some arrangement such that, so I should not allow this instruction to execute after this instruction. So what I'll do, I'll make an arrangement. What is an arrangement? I will skip the second block. So I'll say branch, I'll say skip. So then what I'll do, I'll put the skip here. So now look at here. Now what will happen? If this condition is satisfied, it will execute here and continue the program. It's good. If the condition is not satisfied, it will execute this instruction, but it should not execute this one. For that, what I have done a branching to skip that statement and come to here. So this is a perfect if A less than B condition. So now I have implemented in assembly language, if A is greater than B is there. So okay, anything it's okay. If greater than or less than, whichever you want, you can implement. So I've just implemented. So if A is less than B, I'm doing something. So if it's not condition satisfied, I'm doing something else here. So look at this instruction. What does I have done it? Now we will run this program. I've used to find out so greater than numbers to make a lesser of a number, since it meaning is there. So what I'll do is I'll do the other way. I just change to R2 here and then R1 here. It's nothing but so smallest of the two numbers I'm finding out. This is a program to what? Program to find out smallest of the two numbers. So I given the two number which is smaller here. 100 is a smaller. 100 should be there in R0 register. If the condition is satisfied, it comes here. That is a less condition. Less condition. Then what is a smaller number? So a smaller number will be in R1. That will be moved to R0. So we will run this program and see that how this will work. So now I'll execute the first. Now I got the 64 in A0, that is a 100 and 160 in R1 and R2. Now I'll compare. Now I know that because you are subtracting what? Small. You are subtracting a larger number from a smaller number, larger number from a smaller number. So then what will happen? Carry flag will be clear. So carry flag will be clear. You need not worry about the flags when you implement the logic. Only for your understanding, you just go through the flags also. Now branch less than that. So when does it branch? I said branch, go to the previous instruction. If R1 is less than R2. In this case, what is the value of R1? 100. What is the value of R2? 160. Condition is satisfied. That means that it will branch if R1 is less than R2, then go to the less. 100, it should branch to what? It should skip to this instruction. Keep looking at your cursor. Say cursor is here. It should come to here. Now execute the instruction. See, the cursor came to here directly. It skipped this instruction because why? This condition is satisfied and it is branched to this instruction. Now R0 should be loaded with the smallest number. Now look at that. R0 has got a 64. So that means that among the two numbers 100 and 160, the smallest number is moved to R0. So this how we will use this construct to implement. So what is called as the if, else or equality conditions. Now, so you can, instead of ls, I can use what? EQ I can use, NE I can use it, I can use plus, I can use minus, all six, whatever we have done, we can able to use it. Now, apart from that, I've also introduced now what is called as the plus also I've introduced. Sorry, equal, less than also included. Similarly, there's a greater than also symbol is there. So you can able to use that one. So this is about how you can implement so equality less than greater than for unsigned numbers using branch instructions and compare instructions and also conditional code execution instruction. So if any doubt is there, you can just raise your doubt.